Alrighty, friends, let's start chapter 11. We're going to start with some terminology of things that you probably already know. We're going to do a little bit of like introductory stats and analyzing data, that kind of thing. The term mean in math means average. You'll see it notated with X as a little bar over it. We call it X bar. And you find that, as you know, by taking the total of whatever your values are divided by the number of values. So you add everything up and then you divide by the number of values you had. So I feel like you know how to do that. Median, like in the road, the median's in the middle. So this is going to be your middle value. Keep in mind that the numbers have to be ordered first. And so you have to put them from lowest to highest and then count down to the middle. And then mode is going to be your most common. So it has to be repeated. Sometimes you won't have any. And sometimes you'll have more than one. So you can have more than one or none, meaning maybe none of your numbers repeat, or maybe a couple of numbers repeat the same number of times. So none of them are really the most common. Your max is going to be your highest value. And your minimum is going to be your lowest value. And those come in handy because to find the range, you're going to take the max minus the min. And then that will give you your range as a single value. Now, I'm not sure you've done this before. Lower quartile, or Q1 we call it, is technically like it's the median or middle of the lower end. That's why it's called the lower quartile. So like if you have your minimum and then you have your maximum, and smack dab in the middle you have your median, halfway to the halfway you'll have Q1, so it's the middle of the lower half, and then the upper quartile, or Q3, is halfway, the median or middle of the upper half. So the reason, not necessarily the reason, but quartile has quarter in it, and so you're splitting it into 4 groups, and so fourths. So a quarter is between the minimum and Q1, a quarter of your data is between Q1 and the median, a quarter of your data is between the median and Q3, and the last quarter is between here. So quartile, quarters. So you're dividing each half in half. And then your interquartile range, while range goes for the whole thing from the lowest number to the highest number, I just sort of threw in some extra letters there. Your interquartile range is just going to go from Q1 to Q3. So you'll simply take Q3 minus Q1. So I think some of those terms might actually be newer to you, perhaps. And then an outlier is exactly what you would imagine. It's kind of like a number that's significantly bigger or smaller than all the other numbers. So it's a value. So it can kind of throw your data off. So it's going to be much higher or lower than the other values. So this skews the data, meaning it makes it kind of not super true. And it skews the mean more than anything else. Because if you have one really low score on a test, it can pull the class average down. Whereas it really won't change the mode, because the most common number will still be the most common. And the median in the middle, you're getting rid of the highest and lowest values first as you work your way to the middle. So it doesn't really matter how low that lowest or how high that highest is. So it's just kind of good to know that having a really big or really small number in your data set compared to the others, an outlier like that, is going to skew your mean out of everything. Now these 3 up here, these measure center, like where's the center of your data, and then range, quartiles, outliers, all of that stuff has to do with how spread out is it. So we call those measures of spread, versus measures of center. And actually, I need to extend this down here because it's also going to include standard deviation. Standard deviation has this like little lowercase sigma Greek letter. That's the notation for it. And what it does is it measures how close data is to the center. And we'll look at that a little bit more closely. And the center of the data, by that I mean the mean. So if you say, oh, the average on the test was an 82 and the standard deviation is 3, it means that like most of the data differed from that mean of 82 by 3 points. So maybe up 3, which would be 85 points, down 3, which would be 79. So it's just a measure of like how spread out is the data around, like what's the typical spread around the mean. And that's something we'll dig into a little bit in a future lesson. So those are all terms. I went through them kind of fast, but I also feel like it's stuff you've already done. So we're going to go through and practice finding those numbers again. So the first thing I'm going to need to do is put my data in order. It's telling me these are my final exam scores. So I'm going to find the lowest score and I'm going to go up from there. And to keep track, I usually cross them off. So then I've got that guy. I have a 77 that's next. And I actually have a second 77. So I'm going to get rid of that. Then my next lowest number is an 81. I'm crossing them off so I can kind of keep track of what I've already used and what I'm still looking for. Got an 86, then an 87, and then I've got an 88. Just going through my data set. 89. I have a 90, a 91, running out of room, a 97, and a 100 that I'm going to cram in there at the end. Okay, one thing I'm going to need to know is how many numbers there are, and if you count these up, you're going to find out there's 14 of them. So let's do easy thing first. Do any of them repeat? Yes, only the 77, but that makes that my mode. What about median? So median is going to get rid of like the highest and lowest, and then the next one in, then the next one's in, and so on. I just keep moving one value at a time. Next one's in, next one's in. Now, the median is actually going to end up being in between these since I had two numbers in the middle. So if you think about the value that would be halfway in between 86 and 87, it's going to be 86.5, which if I didn't know how to figure it out, I could have taken the 86, add it to the 87, and divide it in half because you're literally looking for halfway between those. And then the mean, I have to add all the numbers up and then divide by how many there are. So if you added these all up, you get 1160. If you divide by how many there are, you end up with an average or mean of 82.8. I'm going to put a little sad face here because if I look at my numbers, 82.8 would be like right around here. And if I look at how many numbers are in front of that, to the left of that, and how many are above that, it's not really a good measure of center. And I think it might be because of an outlier. Which number do we think is an outlier? If you're looking at these scores, they're all pretty close together except for this one down here. So that's probably throwing off our mean like we talked about. So what is the mean without it? So let's do the mean without the outlier. So then instead of 1160, I'll take out that 45 from my total. And instead of having 14 numbers, I'm going to have 13 numbers. So my new mean when I calculate that is 85.8, which puts me right in this region. And that's a much better measure of center than my old one. And so that is not the mean of the data as it stands, because this is, but I'm just showing you the power of removing that outlier, and it gives you a much better accurate picture of what's happening. All right, so let's bounce back to this, finding the max. That's our highest score, which was a 100. Our lowest was that 45. So the range is going to go like span that distance. So that turns into 55 as a range. Q1, okay. So we split here as our median. So now in the lower half, if I kind of like say eliminate this and this, then move one in, I end up with 77 smack dab in the middle, making that my Q1. So this is the first quarter of my data. This is the next quarter of my data. Zooming over here to find Q3, I'm gonna go top, bottom of that half, top, and then the next one in, next one in, next one in, and so that lands me right at 90. So my Q3 value is 90. So that means the next quarter, or 25% of my data goes to there, and the last quarter, or 25%, goes to 100. So your quartiles are the halfway mark from your halfway mark. So IQR is just taking 90 minus 77. So I have an interquartile range of 13. So I'm going to actually write that the opposite way. So I would take 90 minus 77, Q3 minus Q1, and my interquartile range is 13. So that's how you find the data. Now we're going to talk about a box and whisker plot, and you basically use a 5-number summary. You need your minimum, Q1, median, Q3, and your max value. You're going to plot your minimum, then you put a line at your Q1 value, a line at your median, a line at your Q3, and then a dot at your max. So this connects to the box, this connects to the box, and then each of these boxes is containing 25% of my data. Because this goes to Q1, this is going to represent 25%. Then this goes from Q1 to the median, so that's another 25%, and so on. So the thing to remember here, though, is that these are all perfectly even, and they won't always look that way because it depends on how much the information is spread out. But that's what a box and whisker plot looks like. So if we have one like this, it says test scores as a percent for 9th period. That must have really long school days. So what is the high score on this test? Well, keep in mind how these work. Min, Q1, median, Q3, max. Hey, we're gonna have a dog fight now. That's not okay. I'm making a video. So each of these contains 25% of the data. So the fact that this one's really small compared to the other ones and this one's really small just means that that data was closer together. Because if I need to collect a fourth of the data and I got to go this far to get it, that means it was spread out. If I only need this far to get a fourth of my data, they were really close together. So the highest score here is 102. What percent scored above 72? So that's from here on out. Dolly, come here. So that's 3 sections, and each section is 25%. So 3 times 25 is going to be 75%. Median, that's going to be the line in the middle of the box. That's located at 88. What percent scored between 88 and 96? Well, that is just one section of my graph. And since every box and whisker plot has each section 25%, since it's one section, that's 25%. So do you think this test represents like data showing that the test was too hard for the kids? My answer is going to be no, this was not too hard for them. For one, you have all these kids. You have 75% of the students scoring 72 or higher. So that information was obviously out there. And then, I mean, somebody, that might be an outlier that's really low compared to the others. The other thing is someone got 102. So somebody got over perfect and all the data is kind of crammed in up here on this end. If the data was crammed in on this end, then yeah, I'd say something's not right and kids are not understanding that material. Okay, so we're gonna do a box and whisker plot for our previous data. one of my little dogs is laying underneath me and she has a treat. And then the Great Dane puppy is trying to get it. So they're trying to fight right by where I am. So I'm gonna take a little time out here, steal this treat. Thank you, Penny, and hopefully end that fight. Okay, always an adventure. This is the same data as the other page, so I'm not starting over to figure it all out. I'm gonna steal my numbers from the previous page. So what do I need for a box and whisker plot? I need my min, which we had as 45. My Q1, I'm just looking back, was 77. My median was something, 86.5. Q3 was, we found all this earlier, 90. And then my max is 100. So here's the catch. Like, you look at how low it goes and how high it goes, and you're gonna need a scale that spans all of that. And so I'm gonna start at like 40, and then I'm gonna make this 45, 50, 55, 60, and so on. I'm gonna try to space it evenly so that I can see how spread out stuff is. Just counting by fives. And trying to keep the spacing good. So now when I go to plot my minimum of 45, I put a dot right above 45. Then I go to my Q1 at 77, so that's like over here-ish. And I draw that whisker over. Now we're gonna drink really loud. Then I'm gonna have a line at 86.5, my median, that's like right around here. Then I'm gonna have a line at 90. So because this section is small, it doesn't mean there's less data. It means it's more condensed. Like, this is 25% of my data. This is 25. So like 25% of the kids scored between 45 and 77. 25 scored between 77 and 86.5. But then 25% of this class scored between 86.5 and 90. So a bunch of kids scored in there. So that's why it's short, because it's condensed. World's longest drink. And then the next 25% of kids scored between 90 and 100. So that is how you make a box and whisker plot, how you understand one, how you find all the data. That's everything. I'm gonna go and steal the water from my dog. Bye, guys.